So the question says a curve which has a gradient of dy dx equal to 3x minus 1 passes to the point 41. Find the equation of the curve. So here is the thing. If remember though, when you get the gradient of a function, all right, to go back to the original thing, you're gonna have to take the integral of the gradient, because in order to get the gradient, you would have differentiated a truth. So the truth would have been y is equal to something. So y is equal to some function, right? And after we integrated, differentiated this, we end up getting this. So then we're saying we're gonna integrate 3x minus 1 dx. So we're going to take the indefinite integral. So we're going to go backwards so that when we integrate this now, we're going to get what our thing. So basically, the good thing is we're integrating this and they are separate. There's nothing multiply or anything. So basically, the integral of 3x. So we add, all right? So we add 1 to the x and divide by that, and this becomes x. And then, all right, so basically y is equal to this. When we take the integral, that's where we are now. So if you imagine differentiating this, you would have seen that up there. You get it? Think backwards now, you're seeing it. So that's not the answer though, because there is a c here that we need to sort out, right? We need to sort out the c. But what they did for us here was that we were given a point that the curve passes through. So the fact that you're given a point would have meant that we are able to find a value for c, because this is x and this is y. So we're going to substitute using the point for x equal to 4. Let me fix that. One more. All right. So then we're saying using the fact that x is equal to 4 and y is equal to 1, we are now able to substitute here. So basically, when 1, which is y, is equal to 3 times x squared, which is 4 squared, all over 2, minus x is 4, plus c. And you could see right now how we're going to actually get a value for c, because now we substituted a point that the line passes through in order to find the unknown c right now. So equal to 3 times, what is it, 16? This is 48 over 2 minus 4 plus c. This is like 19. Yes. All right. Let's go. This is 24 minus 4 plus c. 1 is equal to 20 plus c. So negative 19 is equal to c. Subtracting 20 from both sides, negative 19 is equal to c. Therefore, we can now conclude that the original equation was y equal 3x squared over 2 minus x minus 19. All right, it says all working must be clearly shown that the number of runs scored by a cricketer for 18 consecutive innings is illustrated in the following stem and leaf diagram. It says determine the median score. Median is the middle. So we definitely could find the middle of all of these numbers. How many? 18? All right. So if 18 you're looking for, so you know that you're going to fall in the middle. What you could do though is cross off 1, 1. Like you could say, I guess it's the 9th and the 10th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 will be in the middle for real. Because if we have 18 from 1 to 18, half of it is 9 and the other 9. So 9 and the 10th term would have been that. So it's not 9 because this is 19 and this is 24. So we are adding 19 plus 24 divided by 2. You should have it down. Excellent. Excellent pickup. 21.5. Everybody see the point I'm making? Because a lot of times, if you're going fast, you might make an error. Just remember that the moment we're doing this, we just know that these are the, stem leaf, 19, 20, 24. So we're looking at 19 and 24. We have to quickly pick up on that. So the median was that. Calculate the interquartile range of the scores, the Q3 minus Q1. The thing is, we're going to have to find those. Remain half of this and the next half of this. People knew that they used 19 and 24. They tend to look for the middle of these. Wrong. That's going to be a problem. 19 and these were not the median. They help us to find the median, which is between them. So if the median is between them, that means it's like the entire data was split into two halves. One half is all of these, and the other half is all of these. 9, 9 each. So then you're going to find the half of this, which is 10. This is Q1. And the half of this, 1, 2, 3, 4, is 31. Q3. So then it's all about 31 minus 10, and the interquartile range will be 21.
Sir, how did you find those two numbers just now?
Half. Oh, all right, let me go to a principle so you could get a better understanding. 1, 5, 7, 8, 9, 11, 17, 20. Now, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Let me use this to explain. If we try to find the median now, we would have had to use these two numbers. So the median is not them. The median is 8.5. Guys?
Yes, sir. Yes, sir.
Yeah, man. So then what you'll have now, Abriana, is a lower half and an upper half. You need to find the middle of the lower half to get Q1. Find the middle of the upper half to get Q3. Context.
Oh, sir, I see what you're saying. You shouldn't exclude the 8 and the 9.
You mean, yeah, because they are not a part of the median. That's the trick. The median is 8.5.
Yes, sir.
Then, all right, let me show you something. Be careful. 1, 3, 4, 5, 7. What? Where's my word? I want to show you something. 8, 9, 10. In this case, the median is 7. Big difference. 7 is the median for real. It's not a case where you add 7 to something to get a number that's not there. 7 is the median. So then, all you have to do is to find the lower half and then find the upper half of those. Because 7 is the median. There's a big difference. So this is the median here. Q2, which is a part of the data. So we are left now with the other numbers except 7. But in this case down here, the median is no number that we have. It's a number between two numbers that we have. So you could see that the median fell between 9 and 10, which means that this is Q2 and 4 to the left, 4 to the right. It has to be always balanced. You get the point now?
Yes, sir.
So that would have been the response we put here. interquartile range. In the space below, construct a box and whisker plot to illustrate the data and comment on the shape. Okay. Remember with the box and whisker, you need all of these. You need Q1, Q2, Q3, and we have those. And we need the range, the lowest and the highest. So the lowest is, let me look, the lowest is 2 and the highest is 47. So as long as you're going to do the box and whisker, those are what you need. You need Q1, which is 10, Q2, which is 21.5, Q3, which is 31. We need the lowest, which is 2. We need the highest, which is 47. You're always gonna need all of these to do the box and whisker. So we could drop a number line, and then based on the numbers, we're just going to go by 5 until we reach 50, because we go all the way up to 47. You can represent these numbers on. So 2, so we're going to put the box first, all right? So I'm just going to use a freehand. So 10 is here. And we're going to go up to 31, which means we're going past that. A little bit past 30. And you do your box. So this is where let me just highlight it quickly, show you why I'm doing different color. This is where my Q1 is. This is where my Q3 is. And 21.5 is right here. So it's a little bit past 20, and you know, so that's your Q2. All right. Then now you want to have a line from here. You're gonna go to about 47 because that's your max. Hold on, guys. This thing will give me some problem right now. See here, you go to about 47. Yeah. So this is where 47 is. This is 47. This is 31. This is 21.5. I'm just saying you can put it there. This is 10. You can put them there instead of saying Q1, Q2. I'm just doing it for you. And then you go down to 2 to about down here. And you have 2. That's right. So the little comment that you can look at is all right. It's kind of the fact that the median is almost the center. It's not, but it's almost the center of the total things that we're dealing with. Because it's 21 point something, we're going all the way up to 40. So it's almost symmetric, but it's not, because it's not dead center. Another thing that we can look at is the fourth, look at this, fourth quarter, because when you drop your Q1, Q2, Q3, it divides up your data into 4 quarters. One is from here to here, the next one is from here to here, the next one is from here to here, and the fourth quarter is from here to here. You could say that the fourth quarter is the longest. The fourth quartile, it starts from 31 all the way up to 47. It's the longest of the quartiles. You could see that. Basically, you can just comment based on what you see. When they ask about comment, you're talking about stuff like that. Where you see the median, how it compared to the total number of scores. If you see an extra longer quartile than the others, stuff like that.